So this is a problem. Morning we had a discussion how to develop a PLC ladder diagram for this tank filling device simulator problem, right? Now the second part is like visual screen. We have to develop, design and develop and then link it to the main program. So what I'll do is I already saved the program, so I'll open it. It is 3 tanks. Okay. So this is a PLC logic we have done in the morning session. So it is working fine. So now go to the visualization. So name of the file, tank filling. Okay, now this is a screen, so we have to take 3 tanks, right? So tank directly it is not available, means same type of model. So there is a bar displays available. First design the tank one neatly, for example sensors and everything, and then you copy paste it. Okay, so here no scale, we can take it. Then element frame you want it, background, then we want it in vertical. This is okay. Now variable. So first you take the tank. So we have taken the tank. Variable we cannot link it because we have to take it in the PLC program. So first I'll do it for 1 tank and then I'll implement it to 3 tanks. So here if you refer my the video which is already posted in YouTube, right? That is how to create a filling and draining of tank, right? That is using up counter and down counter and blink function blocks. So that we have to make it. This is the main program. This is the main program. So now what I'll do is either see you can add the code in the main program, but it is very long. First of all, it is very long. So if you keep on adding it, then it's very difficult to trace it, right? So you can add a sub main program. This is the main program. You can add a sub program also. Okay, so that will be difficult to you because you have to link the sub programs to the main program. Okay, otherwise I can also link. Okay, what I'll do is go to POU and there is a add object. There this is what sub programs. We are creating sub programs here. So what is that sub program? I can call it as tank 1. Tank 1 is a sub program, but main program is PLC underscore PRG. That is the main program. So in the tank 1 you do the tank 1 programming. So that is, what is the tank 1? It's a standard programming. That is, you take a go to function block, there CTUD, that is up counter and down counter both. I'll take 2 in number and start naming it as blink. So if this option is not coming, means library is missing. Okay. Go to addition library, then utility is required. So just add it. Go back to the programming window. Why this? Okay, blink option now it is available, right? Now what is this function block name? This is B1 and click on OK. Don't type any address because we are declaring the function block. And time high and time low. Here T hash 50 milliseconds. Other time also you can try. But there are other options are coming. 1 minute. Still here box with en, then F2 you have to type, and then user defined programs. This is a tank one. Tank one is a sub program. Tank one is a sub program. I have called it because it is not taking the library. Blink option is not coming here. It's okay. What we'll do is, see, this will be confusing for you. This is little advanced. So what we'll do is I'll go to the main program, and here, what is the programming for tank 1? So we'll take one input and up counter, again one more up counter, but here you have to type blink. So now it is okay. Extra inputs are not available. Okay, this is B1 and this is C1. Click on OK. Time low, that is T hash 5 seconds. And that is one blink. And this question mark you just delete it. Down counter, select the input, right click, insert blocks, then box. In the box you have to type blink. This is B2. Click on OK. And here time frequency is time is same. Filling and draining, rate of filling and rate of draining is same. Time, see, if you change time here, then rate of filling and rate of draining will be different. Okay. Next, reset. Reset I don't want, you just delete it. Load I don't want, delete it. And PV value is 100. Maximum is 100. CV value is important. That is, we'll take one D1 variable. So what is the type? Integer. And do we require this as a global variable? Let us see. Right now we'll take it as a D1 integer. Okay. So here what is the address for this? So we are working on tank 1. When valve 1 is on, tank 1 gets filling, right? So this is what? This is Y1. If Y1 is on, it starts filling. Next, draining. When draining should happen? We will take, say for example, H1. H1 is nothing but is a extra input we are taking it, that will be available in the visualization screen. When you operate H1, the tank 1 will get drained. Okay, so this I will declare it as a global variable because it should exchange data between the screen and the main program. And here actually already we have taken 8 inputs: start, stop, then 6 sensors, tank low, tank height, like that. So that is address is %ix 2.0. Already 1.7 is over. Okay, 2.0 I am taking it because this is a, see, this is not, this input is not planned in the main program. This is extra input we are taking it, so that draining also we are considering. Okay, so that is a %ix 2.0, and I am declaring as a global variable. Okay, H1 means it's a hand valve it is used to drain the tank 1. Okay, so that is done. So now I will link this to the visualization screen. Before that, what we have to take it? We have to take, that is box with EN, then move option. See, D1 is generating values, incrementing and decrementing, but this value should go to the analog output, right? So we use a move command to move the values of counter to the analog output, so that we can simulate the tank filling and draining. Okay, so I'm using move option. Move to where? Analog output 1. What is analog output address? See, if you go to the PLC configuration, there analog modules are there. Analog output means percentage QW7 or percentage QW9. 7 and 9 is used for analog output. Either you can take 7 or either you can take 9. So I will take 7. So I'll name it as AO1, analog output 1. Then I am declaring global variable because it should exchange the data between the screen and the main program, and address is percentage QW7. Okay, so what value I should move? C1 dot CV. C1 dot CV value I should move to the output. Up to here it is over, means it's okay, no confusion. See, this line, this programming is only to simulate the increment value and decrement value. That is nothing but filling and draining. Okay. So now we have to move the value of counter to the analog output so that tank can be filling and draining is possible. So what I'll do is I'll go to the visualization screen. So there, double click on it. There is a variable. Go to variable section, and what is the start value? 0. What is the maximum value? 100. And what is the minimum scale unit? I'll take 1. And the variable section, you have to type AO1. Here some students will make mistake. They type AO only, but A in capital and O in small letter. Or sometimes A and 0 instead of O, they type 0. So they will not get the simulation. So click on OK. And OK, and now we'll see this simulation. I just tank 1 have taken. I'm adjusting the screen here so that we can. Okay. Now, if you go to the simulation mode and then log in, there is one error, word to bool. That means AO1 at the time of declaration, shift F2, I have declared as bool. It should be double word. It's analog value, right? That's the error now. So go to online, login, run. Now what I'll do is first I'll press the start button. When you press start button, what will happen? Y1 is on. Make sure that Y1 is on. Is Y1 is on, and you'll come back. See, Y1 is on here, and why this not working? So it is values 3. Okay, maybe it is 5 seconds. See, this is a mistake we have done. Instead of 5 milliseconds, we have done 5 seconds. So that is why you can expect a long delay there. Milliseconds. Then you press start button. See now filling is going on. Once you press start, Y1 is on. When Y1 is on, I have given a command to fill the tank. But it is crossing 100. See, there is no limitation. So how to avoid this? So we have to use a comparator. So that is box with en and there EQ or greater than equal also you can take it, or equal, actually equal. That is, what is that? Again C1.CV, if it is equal to 100, then I am going to generate one memory bit, say for example M1. M1 is local variable, not global variable, so that M1 can be off, means it can switch off the filling. Filling means what? If Y1 is on, it gives a signal for the blink. Okay, so what I'll do is I will take M1 here, so that after count of 100, M1 is on. When M1 is on, even though Y1 is on, M1 will be open. So it stops applying signals to the counter. So it stops filling. Now go to S1. It's filling, but when it reaches the value of 100, now 100, further it is not filling up, because when it reaches value of 100, what is the status of M1? M1 is true. If M1 is true, this will be open, so that your filling will not happen again. Okay. Now, by operating H1, okay, that is toggling is there. That means you cannot do that. Okay, now give me some ideas. Now we have used the tank 1, filling and draining is over, but we want to simulate like sensors. Sensor is on or off. Correct, right? So what I can do is, this is for only one tank. So one tank, this is the program, and what I'll do is to simulate the sensor type switching of sensors. What we can do it is, we can take a rectangle. Okay, you can take designs. You can just say this is one and this is another one. Okay, so this, whether it is an input or output, sensor actually input to the PLC, but we are not connecting to the PLC, but we want to some indication like sensor on or off. So for visualization, it is considered as output. Okay, so that means what is the condition? Say for example, greater than or equal to, that is CV1.CV, and this one is, say for example, 10. If it is water level is more than 10%, we are switching on one output. Okay, so this is called tank 1 low, tank 1 low. And what is the address? It's a global variable because it should exchange the data between screen and the program. And what is the address? That is percentage QX 1.7. Sorry, it is there. We have used how many outputs? 3 outputs we have already used: 1.0, 1.1, 1.2. Now 1.3 we can use it. QX 1.3. That is for tank low. And if it is same type, So here box with n, again g greater than or equal to, if that is 90%. Because I am placing high level sensor not exactly 100%. You can place it at 100% also. Okay, but C1.CV I am compared to 90%, and then I'll take another variable called tank 1, that is high. This is also output. It's a global variable, and address is %QX 1.4, and these two variables I'll use it in the visualization. I'll click on here and then go to color change or variables. In color change, what I have to type, that is tank 1 high, and content, that is and this one is content is, it's a low level, but variable is color change is required when tank 1, that is low. Color change, I think we are not selected the colors. Go to colors, there by default white will be there, and after change I will put it green. Now go online. It's not okay, it's in turn mode. We'll see low level sensor is on, and when it reaches 90%, high level indication will be there. Okay, and it's not filling further. Okay, this is for one tank, and what way to do it? Start button is already in the program. Only you have to take start button and stop button in the screen. Okay, now say I'll just discuss that. In the go to the screen, there is a start button. So this is start and stop, and there is one more okay, we'll go to the button and then we'll take this is for start, stop, and then here drain. So double click on it. Text I want it as a start. Font size not happy, so we can go for 18. And this one is stop. Variables, go to input. It's a push button, and it is what is a S1, right? S1 variable we have taken, and this one stop, but we are using input as tab variable, that is S2. And this one is go to text, there H1 is a value, that is variable is input, it's a tab input. Should we take tab or toggle? We'll take toggle, right? Toggle, and this is H1. H1 variable, but we are not declared as a global variable. That we have to be very careful, otherwise we will not get output. See here H1 variable, This is h1 variable we're talking about. H1 variable okay, global variable already declared. Fine. Next is, see when you press this one hand, that is drain valve, what should happen? Tank 1 should not be filled. Correct, right? See, if we give a command to drain, then water level comes down. See, what is our equation here? If value is equal to 100, see here, if value equal to 100, then M1 is on. If value is not equal to 100, then what happens? When you start draining process, water level comes down. Correct, right? At that time, you will have a problem. Again, M1 will be off because it's not equal. So what you have to do? Should we take equal or greater than? I think greater than equal. If you take it, then our problem will be solved. It is GE instead of equal. We will take GE. So if it is really tank is full, then only this will M1 will be on. Okay. So let us see this how it's going to work. So start, filling started. It has stopped. Okay. Now if you press H1, oh, there is a problem. That means it is going to fill also, it is going to drain also. That is a problem. So why means if M1 is on, so that is what, if M1 is on, we should give, that is if M1 is on, we'll going to reset the Y1. Where is Y1 reset? We'll go to the Y1 reset and we'll add one parallel contact and we add H1. Correct, right? When you are requesting for draining, filling should not be working. It should not be working, right? So that's what I'm doing. If H1 is on, I'm going to reset Y1 so that I can drain the tank completely. Where is it? Screen. Okay. Start. So filling is started. See, clearly indicating low level sensor is on first, and then high level sensor is on. Okay. Now, if you press H1, it is draining. H1 is not a push button, it is a toggle switch I have taken. Even push button is not required, only toggle switch you have to take. Otherwise, you have to use a set function in the program. So better you take the toggle switch. So I have drained completely the tank. So in this case, if you press start, again your program should be working condition. What happened? It's not working. Oh, Y2 is on, that is why. That means Y2 is already on. Y2 tank we have not taken, right? So we have to press stop once, then start. So like this, I will copy these 3 tanks and then link the variables. The problem will be solved. But the design, you should design, like it should look like industrial equipment type. So like that. So filling is over. Tank 1 is filling is over. Now draining is going on. Draining is like an additional option. Okay. In the program, it is given only for filling. Now, So what I'll do is I'll put some name here. This is what? This is tank 1, and you can create some valves like Y1 is on, all this valves we can create. You can create it. That is design part is there. Say for example, what I'm telling is you can create a pipe type here. Okay, and you can design that using lines. You can design. Okay, so but you do it. That is your part. You do it. This is tank 1. So what I'll do is I'll just copy all these 3, is paste it as a tank 2, then tank 3. So stop, I'll keep it here. And this one is H2, right? So before that, what you have to do it here, go to program. In the program you have to this is tank 3, and this is what? This is text. This is H2. I'm just changing text because I don't have variables. Variables, when do you get variables? You have to go to the program and you have to write the program. See, whatever this program is done, this is for tank 1. Correct, right? So same thing you have to repeat again for tank 2 and tank 3. So I will repeat it, just if whoever not connected, now we can get connected here. So right click, go take a input. I'm programming for tank 2. Tank 2 means Y2, right? If Y2 is on, filling should be started. Correct, right? So here, go to function block, up and down counter, take 2 times, and you can name it as blink. And this one, B1, B2 is already linked for tank 1. B1, B2 are already there. So you have to be carefully, otherwise you will be working on solving errors only. Okay, so now you have taken you are programming for tank 2. Tank 2, that is B3 you start. B3 and B4 is for tank 2. So click on OK. And this we don't want to delete it, and then right click on the CD, means down counter input, then take a inserted blocks, then box you take it, then you type blink. Okay, and what is the name here? B4. Okay, and timings I will maintain the same filling rate, and here 5 milliseconds. You have to be very careful. 5 milliseconds. Filling and draining same frequency. Okay, we don't want reset, deleted, we don't want load. Then PV value is 100, and CV value is required. So now I'll name it as D2. D1 is for T1, right? D2 should be integer. Okay, and should we declare it as a global variable? No, right? No, because we are taking the analog output. So this is the address. Click on OK. Address not required. This is D2. What is the name of the counter? C2. Click on OK. And same, exactly whatever program you have done, same thing is for tank 2. So what I'll do, first box with EN, and this is GE. That means it should not fill more than 100. So what I'll do is 100, and this is C2.CV. We are comparing C2.CV with 100%, and I'll switch on now M2. M1 is for tank 1. Now it is M2, and M2 where I place here, normally close here M2, and here H2 is a hand valve. Second hand valve is for second tank, and this is a global variable because I want to take it from the screen. So percentage IX 2.1, 2.0 for H1. Now when H2 is on, when you are draining, when you are requesting for draining, filling should not be started. So whenever H2 is on, what is your task? You have to switch off Y2. Y2 means filling of tank 2. This is H2. So now I'll go to the visualization screen. I've just programmed it for tank 2. So this one variable is, input is toggle, and it is H2. That is one thing, drain valve. And this tank variable is, okay, that I have not taken. Actually I am going very fast here. See, we forgot to move the value, right? We have taken the second counter, but we should move the value of second counter to where? So we have to take a second analog output. It is move option. Next, what do you want to move? C2 value dot CV to where? Analog output 2, and it should be double word, and then it should be global variable, and address is percentage %QW9, because there are only 2 analog outputs as per the inline modules. So AO2 I have taken. Okay, and do you want to link it to tank low and tank high sensor of tank 2 also, right? So for that, works with EN here, greater than or equal to C2.CV. If it is greater than 10 value, greater than 10%, then I'm going to switch on the tank 2 low. Sorry, this is tank 2 low. Tank 2 low. What is our address? Output or input? It's an output. I want to display. So percentage QX. What is that? 1.2 already taken. 1.3, 1.4 already taken. 1.5 percentage QX 1.5. And the same value, means in the same type, I'll take another box with EN. This is GE, and this is C2.CV, and it is 90%. And here tank 2, that is high, and it is a global variable. Percentage QX 1.3, 1.4 take 1.6, we can take it. Yeah, switch on the AC, it is. AC remote. Okay. So here this tank should be linked to which variable? This is AO2. AO2, and this high level sensor should be linked to, go to variables, here tank 2, and this one variables tank 2 low. See what happens now. You just press the start button. Okay, but tank 3 is showing. Okay, because we just copy paste it, right? This is assumed to be like y1 only. That address is there. I will just delete the address. Right now is not required. Okay. When you press start button first, 1 minute, I just reset completely and then run. No, just copy paste it. So that's why low also working, high also working. Don't worry about third tank. Only focus on, okay, 1 minute, just to avoid the confusion. So this one, I'll remove the variables here. When you press start, actually tank 1, tank 2 we have programmed. Out of tank 1, tank 2, first tank 1 will be get filled as per the program. Tank 1 is finished, right? Now y2 is on, actually y2 is on. We'll go to the program. Means in the program you should indicate, see, you should, if it is real time, means you will be like, sensor is on, so that high level sensor is on, so that water is stopping. But this is a simulation, right? You should tell the program that low level sensor is on and high level sensor is also on, because tank 1 is already filled, so that it will go to the tank 2. Okay, tank 1 is some problem is there. It's going beyond the screen. This is also, I think, no, this is working fine. Okay, now tank 2 is also filled. So we'll see what is the problem. Tank 1, AO1, and the tank 1 greater than or equal to you have taken, right? So when M1 is on, what is the problem? Can anyone guess what is the problem? It's going maybe it is greater than or equal to, that's the problem. Maybe I'll take it here equal. Tank 1 is filling. See, here we are assuming low level sensor is on, but in the program it should change, right? We should manually change it. What's the problem? Tank 2 is not like that. We'll check the values of AO1. Let us see. It is 100. It is everything is perfect. What is the error? One minute, we'll just reset once. What is the tank maximum value? It is 100. What is the problem? Anyone? There is a guess here. What is going on? This is tank 1 and this is H1, but variable should be H1, and this one tank 1 and this variable so problem with the data that means program, because one mistake means it's problematic like this. 110, then moving the value, maybe M1 we have used it, just check it, let's just look at it, what is going on. It is correct as per the even value here showing 100 only. D1 value is 100, but in the display, one minute, there is one option, reset original option is there. Tank 2 is over, means it's perfect. See if it is, it's working. maybe one more value. See, troubleshooting is the one where we are going wrong, so that we have to understand. It should not show more than 100. Here the value, the AO1 is continuously increasing because this is the problem. AO1 AO2 is clearly 100, but AO1 address you have to check it. What is the address we have taken? Shift F2, Q7 we have taken, and AO2 Q9 we have taken, means QW9. QW7, so global variable D word. AO1 value is not restricting to 100. Now it is okay. So now we have to, that is the troubleshooting. So now we have tank 2 low is not working, so we have to see what it is. Tank 2 low. Is a tank 2 low, it is C2 greater than is equal to 10, and tank 2 address we have declared locally, so it is not exchanging data, so it should be declared in the global as well. Okay, so this is tank 2 we have done. Let us see that. Start. So tank 1. After, see, as initial assumption is all 3 tanks are empty. So tank 1 first it is filled. Next it will go to tank 2. Okay, tank 3 we have not done the programming. So if you complete it, then that is also will get over. Okay, next. See, now draining of tank 1, draining of tank 2 also possible. So only pending program is that is tank 3. We have to program it. Done. Let us stop. I can one second you can start it. But now let me do the programming for tank 3. So you can just copy this and paste it and then change the variables. So this is Y3 and this is M3. We have to change it to M3. This is what? B5. This is B6. And here H3. H3 address is global variable because it is sharing the data with screen. and it's a boolean, but a percentage qx 0.3 1.5, this is 1.5. It's a global variable. Then this is d3. It's a local variable, but it should be integer. Okay, this is for tank 3, and here C3. If you make single mistake, you will not get output. Okay, and here what we have to do? Again, box with en. This is EQ. So what I want to compare? C3 dot CV and 100%, then M3. Okay, and also M3 should reset the Y3 also. So go to Y3 and then add parallel here and M3. Okay, and here, sorry, this is H3, right? Even if you can add M3 also. Sorry, this is Y3, right? Y3 reset. M3. So after that, last is like sensors. Sorry, move the value. We have to move the value. See here one problem. We have taken two analog input and two analog output, right? In the inline. But we want, in this program, we want 3 analog output. AO1, AO2, AO3. But in the configuration, you have taken only 2 analog output. So what you have to do? Go to again, append sub element, and again you have to take 2 more analog output to take it. It's a simulation, right? We can take more number of input and output. So now totally in the PLC, whatever PLC we are using is, there are totally 4 analog outputs. Okay. So now go to the program here. We have to move the value box with n. There is a move option, and what do you want to move? C3 dot CV value to AO3. And what is the address of AO3? So that is very important. AO3 address, we'll go to PLC configuration. See here, that is Q 11 and 13. Output is 11 and 13. Sorry, yeah, 11 and 13. So you should go here, and AO3 you have to type it. And it's a universal, sorry, a global variable, and it is a double word, or word also you can take it. And there percentage QW11. That is AO3 address. Next is the last 2 lines, that is the sensors one, box with en, that is EQ, sorry, GE greater than, here C3 dot CV, you have to compare to 10%. 10% means it is tank 3 low. Okay, this is the output. Digital output. So first of all, we have taken 3 outputs, that is 1.2, then 1.3, 1.4, 1.5, 1.6. This is percentage IX 1.7, and the last line, box with en, there it is GE C3 dot CV, and here 90%, and here tank 3 high, and this is boolean but global variable, and address is percentage qx 2.0 because 1.7 is over, so 2.0 AO3. Now we go to the visualization screen, so there we have to link it. And what is this one? This is tank 3. Go to the color change, colors, the color variables. So color change, sorry, variables. There here, tank 3, it is low, and this one, tank 3, it is high, and this one, go to here and then variable AO3, and this one is toggle, but here it is H3. Okay, but just one doubt is there. H3 we declared as input, H3 we are declared as output. It should be input, right? Tank 3 low, that is QX. Run, we'll go to the directly visualization screen. First tank 1 will get filled. Next tank 2. Next tank 3 should be started. It's not working. We'll go to the tank 3. It is Y3. Y3 is not on. Y3. Okay, here we have to assume that, right, tank 2 it is filled. We have to tell the software that tank 2 is also filled. Then you go to the visualization. See, 1 minute. This is, we are working. Sorry, this is, we made a mistake here. Tank 2. Tank 2, we should tell program that tank 2 is filled. Then it will go to tank 3. So tank 2, now tank 2 is a problem. We have to. It's okay now. All 3 tanks are filled. So stop, and then drain. That problem I'll just rectify it. What is the problem? Tank 2 is not draining. Okay, it's drained. Now release all drains, then stop, then start. So first tank 1 will get filled. So tank 2 tank 2 is having some problem, so that we have to solve it. tank to M2 and H2. It is double word is there, we'll make it word. When tank 1 gets filled up, we should update in the program, like sensor, low level sensor is on. So like that we should update in the program. So right now I updated. So tank 1, tank 2, tank 3. Okay. Now you can manually drain it. If you want to manually drain it. Okay. Actually, what is happening? See, whenever tank 1 sensor is on, means you should go to the program. There you have to make changes. Tank 1 sensor is on, and whenever tank 1 sensor, high level sensor is on, you should go to the program. There you have to update that tank 1 high level sensor is on. So that program will sequentially follow first Y1, then Y2, then Y3. So this is a basic design we would have done. So here you can put an inlet valve, then a drain valve, filling valve, drain valve you can add it. Then graphics you can create it. It looks like an industrial equipment type. Okay, since that is your part, I have explained the programming part. I have explained how to link it to the visualization screen. I have explained. So next is you have to take it. Means you have to practice it. This one. So this kind of problems will be there in the technical competition. But the way you are giving expressions, sir, we don't want technical competition like that. Is that true? Still plenty of time. This is only the half of the internship. Okay, so still 10 more days are there. You can prepare well. So this is one I've solved. The assignment number 11, that is your scope. Okay, you have to solve it, and you have to get ready with the visualization screen. Okay, now if you press stop, it stop. Okay, let's say for example, one thing is I'll check the stop function. Stop function, is it working or not? All 3 tanks are empty. Release it. Now you press start, it is filling, but if you press stop, what happens? Stops there. Okay, so it's working. And now you press start again, continue there. Okay, so all the functions are working. Then I'll share the program PDF. I'll share with you. Just go through that. Okay. Any questions? The program is